Hello, let's continue our Sudoku adventure with Cages Matter by Riffclown. So we have normal Sudoku rules and standard killer cages, except we don't have any sums. So what does that mean? Well, Sudoku rules tell us that in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. Additionally, we have these cages in the grid, and it says digits in cages cannot repeat, which means that if I put a 1 here, normally Sudoku would allow me to put a 1 also here. But you can see it's showing up conflicted because you cannot repeat digits within a cage, even if Sudoku rules would normally allow you to. In addition, the sum of the digits, they sum to the total in the upper left corner if given, but none of them are given. So that could have been omitted. But basically what we have is extra regions in the grid. Where digits can't repeat. So we have the normal boxes and it's like an irregular on top of that, as far as I can tell. These cages don't all have to be 6 in size. I haven't counted them all, so you may want to. But as far as I can tell at a glance, that seems to be the case. Anyway, I will be more careful when I get started, but you can definitely try the puzzle out yourself. The link is in the description, and I am going to get started right now. Okay, so I think we should first verify that we have 6 digits in each cage, because that'll really help think about things. This one is 6. That one's 6. That one's 6. Okay, yeah. Every cage is 6 in size. So we can think of these just as extra regions if we want to. So what is a good question to ask? We've got some interesting geometry in some of these. So this cell, for example, if I make this cell green, where does green go in this box, box 5? So it obviously can't repeat in the cage, and it also can't repeat in the column. So there actually is only one spot for it. So green goes there. Can we do anything else similar? This cell, if we make that purple, it can't go here because it's the same cage, and it can't go here because it's the same column. So it's either 5 or whatever this one is. So purple's one of these two. Let's see. These two cells are the same as these two, but we don't know what order they go in. So this box needs a green. It's going to be one of these two. What about this one? We know this one. Let's make it blue. We know it's different than green and purple because they all share a column. So what can we ask about blue? Well, it can't repeat in this cage and it can't repeat in the row. So blue goes here. And then blue can't be in any of these cells. So blue is one of these two. I think we mentioned that these are here. But now we can color that a little bit. This cell here goes here, but it could be green. But these two are definitely the same. I'm tempted to just do this whole column different colors. So orange, and we can just use 3 as 3, but orange, what can we say about orange? I didn't really look ahead, but actually I'm not sure if orange is very useful to think about at the moment. So maybe we don't give it a color yet. And this cell also, okay, this cell goes here because it doesn't repeat in this cage. Okay, so I'm missing something important about one of these things. There's just a lot of interesting geometry in the grid to look at. These two cells go here. But we know that they're not purple or blue, but they could be green. We could have a green up here. I'm wondering if any of these givens are useful geometrically. Well, we know that one of these is a 3, so we can mark that. Because 3 needs to go in this column somewhere, and it can't be in the same cage. 5 goes in one of these two. Okay. That looks over and down. So 5 is one of these two. So 5's just down here. Can't do a whole lot with that. These are the same. Okay, if these are the same, that means they can't be 2, 3, or 5. And just to reiterate, these are the same because this cell needs to go somewhere in this row. And it can't repeat in the cage, so it's got to go here. So these are either 1, 4, or 6, for what it's worth. And they're the same digit. Don't know if there's any interesting geometry to do with that yet. So it goes here somewhere in this cage. Not that interesting yet. Let's see, what else can we do? This 4? This 4 goes in one of these two. Because it's got to go in this row somewhere, and 1 is not 4. That's just normal Sudoku, though. This 3 doesn't go here. Okay, so this cage needs a 3. So I guess I should state, because I don't think I've explicitly stated that because when a cage is 6 in size, and you can't repeat digits, it has every digit. So we can ask questions like, where is the 3 in this cage? And it can't, this 3 is in a prime position to rule out a 4 out of the 6 spots. So 3 goes in here. And, okay, so that will help because we know green is not 3. So these 3s look left, this 3 looks down. Green is not 3, so that places 3 for the box there. Okay. That means that means this is 3. Because 3 can't repeat in the cage, and 3 is not green. So 3 goes here. That's handy. 3 is just down here somewhere. And 3 is in one of these two. Okay, so that's all we can do with 3s for now. We know 3 is not any of our colors that we have so far. So let's just keep that in mind, I guess. Okay, 5 is looking down now. So we know 5, okay, 5 is purple. So where does 5 go in this box? 5 looks down, and we know 5 is not green, because it shares a box with green. So 5 can only go here, and that does make purple 5, so I don't need purple anymore. Which does mean that 5 in this cage goes in one of these two, and we know 5 is not blue. So 5 is here. So that's not 5, so 5 is here. And this isn't 5, so 5 is here. That's where our corner marks come in handy. And I think, do we have all the 5s placed? No, we have one more 5 to place. It's here, so, oh no, it's right here. We know 5 is not blue, so that means this is blue. We still don't know the value of it. Although it is down to, it looks like 3 digits. It could be 1, 2, or 6. Oh, it's not 2, because it shares a column with 2 as well. So 1 or 6 only. How about green? What can green be? I think also 1, 2, or 6. Oh, but not 1, because it shares a box with 1. Okay. My scanning is not doing well today. Leaning a bit much on the red marks, but that's okay. This is also 2. Oh, this is also 2 or 6. Right. Where does 1 go? Was the question. So blue is 1. And then this is also 2, 6. Let's just for fun, let's mark purple as being the other 2, 6. Since we have a color for 2, 6, might as well give it another color. That leaves this for 4. So this is 2, 6, 3. This isn't a 2 because it's in the column. So what's left in this column? 3, 4, and 6. And this can't be 3. Okay. So one of these is purple. But I don't know which one. Oh, this isn't 4 anymore. That's handy. Okay, what question do I want to ask? Well, how about just what's in this column? 2, 4, and 6 also. We know that one of these is purple. This is 2, 4, or 6. 2, 3, 6 here, but no 2, so only 3, 6. So this isn't 2 or 3. or 1, 4, 5. So it can only be 6. So that's handy. So none of these are 6s. That's not 6 either. So we have 1, 5, and 6 here. So this is... so where's 6 in this row? That's the good question. Can't be repeated in this cage, so the row can only put a 6 here. That does make green 2s, purple 6s. We need a 2 up here. It can't be here, so the 2's here. And then our red marks do tell us what the rest of these are. All right, so let's get rid of our colors. And I think we should be finishing up. So this is a 6. 4. We got a 3 here. That's a 6. 4 and 6. This can only be 3. That's a 2. That's a 3. Oh, I got a 3 in the corner and it sprayed confetti. That's funny. That's a 4 and that's a 2. All right. Cool. It does look like we got a little bit of a style upgrade for the app as well. These buttons are a little prettier. At least it seems like they are. All right. Well, cool. Well, thank you, Riffclown. That was a neat puzzle. A nice demonstration of how you can utilize these extra regions to make for some cool logic. So hope you guys enjoyed that. And if you did enjoy this puzzle, then why not leave a like, subscribe, and a kind comment below.